Chapter 12, Solutions. Why shouldn't you drink seawater?
Dirty.
Well, it's dirty, but salt water.
It takes
Why is the salt bad?
because it makes it.
It'll dehydrate you.
It'll
because of,
dehydrate you. Yeah.
Osmosis. It'll pull the
Osmosis,
water
yes.
out to give the water to
Drinking salty water will actually cause your body to lose water. You won't absorb water from it. We say that seawater is a thirsty solution. The solution draws more water to itself. And that's one of the things we'll be looking at in this chapter. So seawater is a solution. In everyday life, solutions are answers to problems, right? Not in chemistry. It's a homogeneous mixture of two or more substances. So homogeneous, the same throughout. It has two parts, the solvent and the solute. The solvent is the part that there's more of. So a solution has at least two compounds in it. And there's going to be more of one than of the other, unless you rig it up really, really carefully, and we could discuss that on an individual basis. But generally, there's one that there's a lot more of. Oftentimes, that's water. That's called the solvent. That's what the other stuff is dissolved in. Everything else is called the solute. You can have more than one solute in a solution. In the ocean, we have a lot of water, and there's sodium chloride, that's one solute. There's also magnesium chloride and all kinds of other salts that are dissolved. All of those things that are dissolved in the water are solutes.
How come when the chlorine and the sodium get separated, they still maintain the properties of salt?
How is that? When the sodium and the chloride get separated, they maintain the properties of salt. Well, they do and they don't. Because an aqueous solution has some different properties than crystals of salt, right? The density's different, the boiling point's different. They're going to taste similarly, but when you taste solid salt, what happens to it when you put it in your wet mouth? It dissolves in water.
But pure sodium reacts with water. That's
Yes, pure sodium. Okay, I get what you're talking about. But this is not pure sodium. These are sodium ions.
Because
It's still lost an electron. Yeah.
Okay.
So yes, sodium, the metal, and chlorine, the elemental gas, have very, very different properties than sodium chloride.
Okay.
But sodium chloride, we're just separating the sodium and the chloride ions, and we can put them back together. And so this is not a chemical change, it's a physical change of mixing. Good question. I just didn't get it at first. Nature has a tendency toward spontaneous mixing unless it's highly unfavorable energetically. And we can observe things like this in everyday life. If you drop a deck of playing cards that's not in a box or tied with a rubber band, what happens? They go all over the place. When the leaves come off of a tree in the fall, they don't stack themselves up. They are actually somewhat organized in the tree, aren't they? If you look at a tree, you people are studying biology, you go up the branch and there's little branches coming off and there's leaves in certain patterns. When they come off the tree, though, they get all mixed up in chaos, right? So we know that nature tends to do this. We're going to look at why. So here we have an illustration of a tank of water. There's a removable barrier in here. On one side we have pure water, and on the other side we have a solution of sodium chloride in water. Now if we pull this barrier out, you could pull it out really, really carefully so it doesn't disturb the solution. Is all the salt going to stay on that side? No. It's going to mix. Because that's what nature does. Nature tends to spread out and to mix things together. Back to the why you shouldn't drink seawater. Well, here we have an illustration of what's going on in your gut. So this is inside your cells, and this is in your intestinal tract. So if you have salt water coming in here, that's got a higher concentration of sodium and chloride than the sodium and chloride that's within your cells. Nature wants these to mix. Your intestine, the wall of your intestine is a semi-permeable membrane. It allows water molecules to flow through it, but not dissolved solids. And so the water flows through because it's trying to equalize the concentrations. And so drinking salt water, instead of the water going into your body because you're thirsty, more water comes out and you get more thirsty and more dehydrated.